Welcome to Chapter 6, Chemical Equilibrium. Now I will show some example. The composition of sulfur trioxide to sulfur dioxide and oxygen is a reversible reaction. Then 2.5 gram of sulfur trioxide is inserted into a 37 ml flask at 25 degrees Celsius. At equilibrium, oxygen concentration equals to 0.015 molar. Calculate the equilibrium constant for this reaction. Okay, so the first thing, because the reversible reaction equation is not given, so we have to write on our own. So write down first, sulfur trioxide decompose to sulfur dioxide plus oxygen gas. Next, we check whether the reversible reaction equation is balanced or not. Okay, so what we do is we just need to multiply by 2 to make it a balanced reversible reaction equation. Now, since we need to find what is Kc, okay, let's say Kc I write down here because I know I need to build up istable. Okay, so I put down here first. Kc, the expression would be product over reactant. So don't forget that the coefficient is 2, so we write power of 2. Then later we need to substitute each concentration at equilibrium into the Kc expression. Okay, now let's see what other information that we have now. Okay, so this 2.5 gram of sulfur trioxide is inserted. So means this is the initial number of mole or initial concentration. Then we have at equilibrium 0.01. Okay, so what 0.015? So what we can do is we can construct an istable first, initial, change, and also equilibrium. Now, as we know, we only know that this is for oxygen, it is 0.015. So we also know initially there is no product formed yet. And then we know that for changes, it will form 2 times, okay, based on the stoichiometric coefficient. So for oxygen, it will be x. Okay, so at equilibrium, we will get 2x, and then we also get x. So x, we know that now, x equals to 0.015. For initial reactant, SO3, we don't have concentration because they only give us in gram. So now means that we need to change mole of SO3 2.5 over molar mass 32 plus 48. So we will get 0.03125 mole. Okay, this is just mole, but we need to get concentration. So concentration of SO3 equals to mole per volume. Volume given is ml. So remember to change to liter. So it is 0.375. So the final answer is 0.0833 molar. So this is our initial concentration. So we put it here 0.0833. And then we know if it's a reactant will reduce. So how many times? 2 times because of the coefficient. So balance, at equilibrium balance, we have 0.0833 minus 2x. Okay, now we have our complete ice table. Now let's see how can we get all the concentration for equilibrium, because we need to substitute the equilibrium concentration into Kc. Okay, so now we find out that x equals to 0.015. So this one will be 2 times 0.015 for SO2. So we get 0.030, and then for sulfur trioxide, we will get 0.0833 minus 2, 0.015. Then the answer will be equals to 0.0533. Alright, now we shall substitute all the value found at equilibrium into the Kc expression. So we have SO2 is 0.030, oxygen is 0.015, and then sulfur trioxide is 0.0533. Then remember, don't forget the power, okay, power of 2. Then our final answer is 2.38 times 10 to the power of negative 3. So remember, balance the reversible reaction with phase and arrow, then build the ice table and fill in as many information as you can in the ice table. Then remember, for Kc, all the concentration must be from equilibrium. Next example. This time, the reversible reaction equation is given. So it is given here. The concentration in a closed container is found to be 0.57 and 0.17. Again, it mentioned at equilibrium. Calculates the equilibrium constant. So we want to know what is the equilibrium constant, and also initial concentration of NO2. So rewrite the reversible reaction equation, and since we want to find Kc and also initial concentration, so we build ice table for concentration. So initial with unit, change, and then equilibrium. Now let's do one by one. Okay, it says that at equilibrium we have 0.57 NO2 and 0.17 and 2O4. Now let's try to fill up the ice table. Same thing again. This is product and nothing is mentioned about the product, so no product form initially, so it's 0. And then when it start to form, we put plus x because it's just 1 mole. Then we have, finally we will have x. So we know that it's 0.17 means x equals to 0.17. Now for NO2, we need to find what is the initial concentration. So for initial concentration, let's say we put Y. And then changes means that it will reduce by 2x. Don't forget it is 2 because of the coefficient. Now the first thing we can try to find is Kc, because we have all the concentration at equilibrium. So write down the expression for Kc first. Product over reactant. Don't forget to square, and then substitute the value 57 power 2, then we will get 0.52. Now, next one, we need to find what is y. Okay, so from here we already find out what is x. So means that y plus 2x is the initial concentration, because y minus 2x equals to 0.57. Okay, so now what we do is y minus 2x equals to 0.57, okay, for the equilibrium. So now y equals to 0.57 plus 2x. Okay, so now write down 0. Plus 2 times 0.17, so we will get 0.91 molar. So same thing again, always start with reversible reaction equation, fill up the ice table, and then for Kc, remember to write the constant expression and don't forget the power. Okay, so that's all for the example shown for ice table.